a long time on it, but all of this is one homework. 2.4 and 2.5 is combined in one section of homework, and there's only 10 questions in it. So we're practically going through this in detail because probably one of the more confusing section. So here we're talking about exponential decay. Let's make sure I am recording this right. So here we're going to talk about exponential growth. This was actually 2.4. This is what we just covered, right? Along with the limited growth. The only difference between growth and decay is the shape of the curve. And because the curve is that shape, and we have talked about this before, it's a negative here in front of that rate, which is a reflection around the y-axis. I remember someone saying that last class. So this is exponential decay. And I think we mentioned a couple of examples of this, right? We talk about radiation, and I think we talk about the value of a car, right? The minute you drive it out a lot, that's when it loses the most value. So this, so this is the equation for the exponential decay. The only main difference is, once again, the negative in front of the exponent. So everything else is the same that we have looked at before in 2.4. So here, let's look at this question. So this is number 7 in the homework in my math lab. So it says a chemical substance has a decay rate of 6.8% per day, and the rate of change of an amount n of the chemical after t days is given by dn by dt is equal to negative 0.68 n. So let n0 represent the amount of substance present at t equal to 0. Find the exponential function that models the decay. Anyone wants to give this a shot? You guys need some help on this? All right. Remember, all these exponential functions are modeled by one equation, right? Y is equal to C e to the kt, right? So it's just a matter of filling in all of that. What does C represent? Come on, what does the C represent? No one remembers this? Well, C here, if you forgot, is always the initial amount, right? It's the initial amount that you're investing. It's the initial cost of the painting, right? That's the initial amount. So what's our initial amount in this problem? What did they say the initial amount is? Oh.
6.8.
What?
6.8.
6.8. No, that's the decay rate. So that's K, right? And remember here, once again, this is K times N, right? So N prime of T. So the decay rate is 6.8. So we have that. So that's e to the negative 0.068 t. So what is our c? They tell us. They didn't give us a number, but they said what? Let n0 represent the amount of substance at t is equal to 0. When t is equal to 0, that's the initial amount. What is y in this problem? N, it's the amount. And so that's our exponential function. Do not forget, these are all modeled by this. Same thing we just did. So n is equal to n sub 0 e to the negative 0.068 t. Now let's go part B. Suppose that 800 grams of a substance is present at t equal to 0. How much will remain after t 2 days? All right, so where is this 800 going now? There you go. So this is the initial amount. And how do we know that? Because it's when t is equal to 0. So now they're finally giving us a value for n0, the initial amount. So we know that n is equal to 800 e to the negative 0.068 times t. Now, they want us to find this after 2 days. So we're going to plug in the 2 for t. What do we get for this?
$698.274.
698.27. Okay. 698 grams. So after 2 days, we have 698. What is the rate of change of the amount of substance after 2 days? So here we're trying to find rate of change. We know is n prime of t and of 2. Well, they already told us from the very beginning that this was equal to negative 0.068 n. So absolutely nothing different from what we just did in the previous section, except the exponent is negative. So this is negative 0.068 times 698.27, because we just calculated that. What do we get for this?
Negative 47.482.
Negative 47.482. So that's grams per day. So it's decreasing at 47.482 grams per day. After how many days will half the original amount of the substance remain? . How do we find that? Well, we know 800. What's a half of that? $400, right? So we could go back to the formula. We know that n of t is equal to, what is it? 800 e to the negative 0.068 t. So we have 400 is equal to the 800 e to the negative 0.068, and we're solving for t. So we divide by 800, which ends up being 1/2, and this becomes e to the negative 0.068 t, and then we're going to take the ln of both sides, and this just cancels out. So we're left with negative 0.068 t is equal to negative something here. What's the ln of 1/2?
Negative 0.693.
Negative 0.693, so negative 0.693 divided by negative 0.068. So which gives us that the half-life is
About 10 days.
about 10 days. Okay. No, after all this manipulation, we probably could have gone back to the formula that we did for double time in some of the previous section. If you remember that, we said a double time t is equal to the ln of 2 over k. You guys remember that formula? When we did some of the problems, how long does it take to double your money? In actuality, the half-life formula is actually the same thing. The half-life t is equal to the ln of 2 over k. So without going through all of this algebra, let's try the ln of 2 over k, which was 0.068. That's our k. The negative is in front of the k, right? So k itself is not negative. So what's the ln of 2 divided by 0.068? Did anyone get an answer for that?
Still the same answer, 10 days.
There you go, 10 days, right? So you see, it's the same thing, right? So without doing, every time they ask you to find half-life or double time, just use this formula instead of going through all that algebra that we just did. Clear on that? All right, so let's look at the next problem in MyMATLAB. Hey, look, number 8. Says the half-life for a particular product is 19 minutes. Find the decay rate of the element. I wonder which formula we're going to use for this. What do you think we're using? Double time or half-life formula, right? It's the same formula. So T is equal to ln of 2 over K. They gave us the time, this is equal to T, and we're trying to find a decay rate, which is K. So we can manipulate this formula, right? So we know that 19 is equal to the ln of 2 over k. How do we solve that? Well, we could multiply both sides by k, or we could do the cross product. So 19k is equal to the ln of 2, then divide by outside by 19. Then k is equal to whatever that comes up to be. Sure, you guys will tell me.
0.036.
0.036. Okay, I'll buy that. That was number 8. Let's see what they're. All right, and they actually wanted it in terms of the percentage. So what's that as a percentage?
3.6.
3.6. So it's equal to 3.6. So the decay rate is equal to 3.6%. Agreed.